Good afternoon, everyone. I welcome you all to this 25th module of Fundamental of Internet of Things. Today, we'll be talking about design challenges which are faced by the researchers while trying to deploy the simulated model onto the real-time scenario. So, there is a lot of difference when we are investigating something theoretically or trying to simulate the scenario, but when we actually deploy that into the field, a lot of difference is there and a lot of things are to be taken care of. So today we'll be seeing what are the various issues that come in front of the engineers when they try to deploy the wireless sensor networks. So the first one is heterogeneity. Now we defined a heterogeneous network as a network which heterogeneous network can be defined as a network which has entities of different shapes and sizes. If suppose this is a internet of thing scenario, then it has to incorporate tiniest sensors and various types of sensors which it has to incorporate. It has to communicate with the servers, and in fact the thousands of racks of servers. The sensors communicate with each other, they communicate with the integrating PC or a laptop. The information, if required, has to be transmitted on a smart variable of the designer, and a number of things. The information is uploaded to what you call as cloud. Now these sensors, they are of different make, they are of different what you call as sizes, different capacities. They differ in the processing capacity, they have different make, they have different processing capacity, different storage capacity. Above all, they have different initial energy levels. There are some laptops which can be recharged. Then there are sensors that are deployed in hostile environments. We can't even replace their battery. So when we are designing a wireless sensor network with the mind to upgrade it to an Internet of Things level, heterogeneity plays a very various role. These devices have to, why heterogeneity? These devices has to talk to each other. That day I told you some of the sensors are small enough to even what you call as communicate directly with the internet. That is they are not compatible with what you call as, they are not compatible with TCP IP. They don't have the analysis tool so that they can segregate the data and only send the filtered data over to the what you call as network. They can't even store 100 MB of data. Now these kind of devices, when you expect them to communicate with the laptop, there has to be some channel between them. There has to be some modulator which integrates one type of device with the another type of device. That is heterogeneity. These devices actually in IoT environment should be talking to each other without any human intervention. So a lot of protocols, a lot of algorithms, a lot of calibration is to be done to make this transition possible. So heterogeneous, we defined that day that heterogeneous is basically a network. Heterogeneous is basically a network that incorporates various devices of various types and all various entities of different energy processing and storage capacity, forms a network that is known as heterogeneous network. The same way distributed processing is required. The algorithm, we know that WSN is basically a network, ad hoc network, which operates without any centralized backbone. But to actually make this thing happen, we actually need a distributed processing. Now, we need an algorithm that is basically centralized as the processing is carried out on the different nodes. That algorithm should take the information from the node and send the information to the another node or a gateway device or a edge of the device. It should be playing role of manager of the whole network, which makes this integration possible. We are very much aware of the fact that our bandwidth is actually limited. The bandwidth is actually limited. When we talk about GSM communication band, we talk about 900 megahertz, the bandwidth is fixed. So this communication bandwidth is fixed, and nowadays number of mobile phones are exploding. If we are transmitting the undue data over to the network, we are wasting the bandwidth, wasting unnecessary money. So this communication between the sensors should take place in a manner so that only a meaningful data which would actually generate some actuating feedback should be transmitted over the network. Then we talk about that large scale coordination or scalability. Yesterday we talked about scalability. We talked about that sensor network should be scalable. Same way, if the network, suppose we have deployed a sensor network on 100 nodes, tomorrow this 100 nodes become 200. After 5 years down the line, they might become 2000 nodes or 200,000 nodes. We need a kind of a protocol that is scalable so as to it can coordinate with the small sensor network. It starts working with the small network, it starts working with a very small network and goes on dealing with thousands of nodes. Deals with thousands of nodes. Just a second, lecture now. So large scale coordination is also very much important. Now let's take a small example. Large scale coordination, there is a small sensor network of nodes with initial energy 1 joule. It is tomorrow integrated with a network with the thousands of sensors, 10,000s of sensors with an initial energy of 5 joules, and they are required to collaboratively send the information to the base station. So these kind of coordinations of these kind of requirement often pops up. So this should be, when you design a routing protocol or algorithm for a WSN communication, you should take this thing in a mind. Now utilization of sensor, we know that sensor is a constrained device, low energy, low processing capacity, low storage devices, and it is actually a backbone of a network. It is the one which is required to sense, process and send the information. So this all sensing, storage, processing of the information should be done in such a manner so as to utilize the sensors in a most effective manner. They should always be taken care of. Then the real-time computation, lot of emergency applications we talked previously, lot of emergency applications and other things, they require the real-time attention, real-time feedback to be generated. So this should also be integrated in the sensor network design. Now these are the design challenges of wireless sensor network. Now let's take a look of operational challenges. Now this is more or less, it is easily understandable. We have talked in detail about the what you call as energy efficiency. We have talked in detail about the energy efficiency. We know that the sensors are the constrained device. So whenever sensor network is operating, now when suppose now taking it once again, let's give it a look. Sensor is deployed, it's thrown in a wireless sensor sensing field. It's thrown in a sensing field. It has to identify who all its neighbors are. Then sometimes it has to identify who all are its second tier neighbor. This is first tier neighbor, this is second tier neighbor. Means if this node has to communicate with this node, it will translate the message to it and it will go in a 2 hop. So these all are 2 tier neighbors of sensor network. So depending upon its neighbor, it adjusts and it transmits its hello messages and all. Sometimes sensors are required to adjust themselves. Then they are required to know their location and transmit that information to the base station. Then they are required to sense the information. They are required to sense the information, process it, and transmit it. And what you call as and transmit that information. Now you should always know amount of energy which is used in what you call as transmitting this information, amount of energy used in transmitting the information is exponent 90% as compared to the energy required in rest all sensing storage, and this is the most energy dispersing phenomena which sensor network does. So energy is something which has to be used very properly in a most optimal manner. Then the limited storage and computation, we know that sensors are constrained devices, so that is why edge scenarios, fog scenarios, they come. Bandwidth we have talked about couple of times. Normally then when we talk about wireless communication, one problem that takes place for signal to travel from transmitter to receiver is through a wireless medium. One problem is that signal decays exponentially. Another problem is that when it is traveling through a wireless medium, lot of noise gets induced. It gets induced on a signal. So when we receive a signal, we have to filter it and reconstruct the original signal. Then node failure. Node might drain its energy. Node might be damaged or maybe captured by the enemy. So all these things, when we talk about WSN, we say that it is basically a process which is uncertainties are endemic to wireless sensor networks. Wireless communication is a lot of dependent on environmental changes, so a lot of losses they incur with the environment changing. So these kind of and we know that these sensors, they talk with each other in a wireless medium, so they should be robust enough to combat all these challenges. Then scalability we know, and then survivability in a harsh environment. They are placed sometimes at a minus 40 degree centigrade, another time they are deployed to face the forest fire phenomena. Suppose 50 डिग्री 60 डिग्री से सेंस करके इन्फॉर्मेशन देनी है और वो खुद ही ख़राब हो गया, तो इट्स अ प्रॉब्लम. यू शुड डिज़ाइन देम in a very robust manner. Then this last part, this leaves us with this what you call as last part, and this actually tells we need to write first question on assignment, that what are the experiments experiments are time and space intensive. We have to write a note on this point. Try and find out in net, and when this unit is over, I'll ask you to submit 2-3 questions. One of the question